Hey guys, it's Justin here. Welcome to another quick tutorial. I'm going to go ahead and split this into, I think, 3 sections. We'll see. The goal of this tutorial is going to be making a more complex Eurorack module. By more complex, I just mean it's going to have stacked PCBs. And then part of this is that it is also, it has a couple of footprints in it in the schematic that are, you could probably find them in the library, but I think they're good teaching examples, or at least one of them I think you can find, but one of them is pretty unique. So we'll use that as a chance to make our own schematic symbol and footprints, and that's going to be the topic of this first video. So let's dive in. I'm going to go ahead and create a new project. We'll call this one, oh yeah, I forgot to introduce what we're doing. Let's see here. Alright, so I was thought about making a Buchla low-pass gate Eurorack module. That's kind of my goal here. So I clicked on the first after the search, got this Mod Wiggler forum, and in there is this document from modular.phonic.de, and if you open that nicely done PDF, you get 2 schematics. The first one on the bottom is the original. Well, this is the one that Peter Grenader, I'm not sure how you say it. He did this one, and then Matthias Edeman did this one here, and it's he just adapted it. I'm going to go ahead and rotate this clockwise so we can see what we're looking at. So this is the schematic we're going to do for this module. This one's running at 15 volts. I don't see anything that would prevent it from running at 12 volts. So hopefully my assumption is correct, and if it doesn't work, then I will certainly report that. So anyways, the footprint that we need is this Vactrol. So this is a 5-pin Vactrol, VTL5C3/2. So it has 2 pins for the light emitting diode, and then it has 3 pins for the photoresistors. I guess there's 2 photoresistors inside. I don't understand the mechanics of it, but that's what this schematic calls for. If you look at Matthias's footprint here, he's got this nice little footprint with 5 pins, and so that's what we're going to replicate first for our project here. Now the other one that we'll have to do is this 3-pole, whoops, going a little crazy, this 3-pole double throw switch, which is an on-off-on switch. Of course, I looked in my junk pile and I found some beautiful 3-pole switches. Unfortunately, they're on-on, so they won't work for this application. So I had to order some. I went to this nice website called Love My Switches, which is kind of geared towards making guitar pedals, but a lot of the stuff translates to modular. If you go in the switch section, he's got a 3-pole double throw section. And the one I'm going to use is this one here, the on-off-on switch PCB mount. So I'll go ahead and click on that. And the nice thing is we have a nice diagram here that we can use to create our schematic. Our schematic symbol, and then also our footprint. So let's dive in with the, first we're going to do this Vactrol. Okay, so we need to create the symbol, and then we also need to create the footprint. So how do we do that? Let's start and make our new project. We'll call this the Buchla, what was it, 292, right? Yep. 292 LPG clone. And we'll save that. Alright, now we've got our project. We'll go ahead and save that. And we got to create a schematic symbol. So we'll go to File, New, and then Symbol. Now from experience, I know I want to zoom in quite a bit and make my symbol not too huge. If you make it real big, then you're going to have issues. So if we look back at our symbol here, we've got the diode is in one section, and then the other part is in this section here. So how do we accomplish that? Well, we need sub symbols, right? So we're going to go ahead and save this symbol. We're going to call it VTL. Oops, I messed it up. VTL 5C3/2. 5, 3, C/2. Okay, and we can put Vactrol there. And let's save that. Okay, now I'm going to close it. And I'm going to go into my library. Now I want to go into my library, and you'll see I just created this one here. And what I want to do is right click on it, and you'll see add subpart. Now we have a subpart. And then I'm going to right click again, and we'll add another subpart because we need two, right? The diode and then the photo resistors. So I'm going to double click on this first, or actually I'm going to right click and edit. Now I'm editing just that symbol, right? This is the diode one, so I'm going to zoom in again, and I'm going to pick the line. Now we need to change, well here, let me do one line here. This is going to be the line of the diode. Now I need the triangle, so I'll do another line. Let's see how it's going to look. Let's try that. Not bad. Alright, so we've got our diode symbol, and then we need two pins. If we look back at this one, he's got pin 1 on this side and pin 2 on this side. So we'll go ahead and use that. Now remember, with our pins, the circle part is where you're going to connect in the schematic. So I need to rotate this twice and do like that. Actually, let me do a little more drawing first, I think. Let's make a box. I think that'll look better. Let's try that. So I'm just gonna, let's go one bigger. Yeah, that's what I like. There we go. Let's do it like this. Let's see how that works out here. So pin number 1, oops, well, it's okay that it's messed up with the pin numbering. We'll fix that. You can rotate with the R key, remember? And we've got our two pins. We need to adjust the numbering because of the way I did it. I'll put a 1 here. In these boxes, you can just click and then change the number, which is nice. You don't have to highlight. It automatically highlights. Alright, we got pin 1 and pin 2. So we're done with the first schematic. We'll save that. I'll close that, and let's go back to the library, and we'll want to do the second one, and we'll hit edit. Same thing, I'm going to zoom in. This one's a little bit more complicated. We got a little resistor deal and another resistor deal, so I will create, let's see, so what I'm going to do, I want a little better control. I'm going to change the snap size to 1, and I did that by right clicking, choosing snap size 1. It was on 10, just so you know. And I'm going to make my middle section here, middle line, right? And then we're going to have a little line coming down. Now I need the resistor part. And if we look at his symbol, it goes up, down, up, down, up, down, up, back to the middle. So let's go up. Let's see. Down, down. There we go. And go up. Now remember, this, you don't have to do this with precision. It's just a schematic symbol. Obviously you want your stuff to look nice. Let's see if we can copy this. So I'm going to do a Control-C, Control-V, and we're going to copy that for the other side. There we go. Now we've got our basic symbol. If we look back at this one, he's got the line coming to the edge of the box. So we're good there. We can just put a little line here. And the one thing I want to do first is, well, let's see. Yeah, okay. That'll work. Let me go all the way to here. Oops, messed that up, didn't I? Click, click, right click, 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 right click. Alright, so now we've got our main symbol done. So let's go ahead and do a box. It's going to look like this. And my experience tells me I want the box to be one bigger so that that pin number, there we go, will show up in there. There we go. So this is going to be pin 1. Okay, it's not actually going to be pin 1, right? Because we already used pin 1 on the other part of the schematic. We're going to call that pin 3. rotate. I'm going to have pin 4. Rotate. We'll have pin 5. Okay, and remember, you want these pads to show up on the intersection of your grid, okay, which is a 10 by 10. There's no units here because we're not doing, it's not a mechanical part, it's just a drawing. So there's no units, but the snap is based on that. So we got to change these numbers. This is going to be 1, 2, 3, right? And 4, 4, 4, 5, 5, 5. Okay, now we'll save that. And we have our second symbol done. We can close that out. Now, when we go to our library, let's see how we're doing. We've got the two parts here. I'll click on the first one, drag it down here, and something went wrong. Where is it? Give me a second, and I'll be right back. Okay, I figured out what the bug is. When you right-click and then you do your edit, and you right-click and you do your edit, when you come back here, even if you change your items, this will not show up here. Okay, so what you need to do is go to a different library, open that up, and then go back to your library and reopen that, and you should see the schematic symbol. So it's a kind of a refresh bug. It doesn't refresh until after you've exited and come back in. So we've selected our first part of the schematic. We'll stick it there, and then I'll select my second part and stick it here. Hit cancel. Right click to get rid of that, and I'll double check that we're good. So now the designator is U, which is kind of the default designator when you make a new schematic symbol. So you can change that to SW. I'll show you that on the next one, or you can change it to whatever you want. We'll leave it as U for this one. Alright, so we've created our new schematic symbols. Now we next need to create the actual footprint for this item. So we'll go to File, New, and we'll go to Footprint. Alright, so let me change the background to white. I think that works a little better. Background, white, grid color, black, update. Alright. Now let's talk about footprints. What we need to do is look at our schematic symbol. This one's a little different because I don't have a diagram to take this this hole placement. Now these are leads that stick out of the Vactrol, so they can be bent and shaped. So these pin positions are not as precise as needed, but we can figure a little bit out here by looking at the pin spacing of this this op amp. So we know we've got 0.1 here between these pads, and so thankfully he kept everything on line here. He did a really nice job of lining everything on this 0.1 grid. So that helps us create our schematic symbol. We know that we have 1, 2, 3, 4, 5, 6, so 0.6 between vertically, and then these are going to be 0.1, but these ones are centered off the axis. So hopefully that makes sense. Let me go ahead and show you how to recreate this schematic or this footprint as you were in the footprint editor. So we're going to start. One thing that makes it hard is you can't see the origin too super well when this display. Let me see if I can fix that real quick. Let's make the grid color dark gray. No, still not so hot. Let me try. By the way, I am partially colorblind, so I sometimes struggle with the display. So if it doesn't okay, that's better for me anyways. I can see the origin there. So if my color choices don't make sense to you, then that's why. Hopefully you guys can see it. So let's talk about that footprint. We know we need a 0.1 spacing. So we go to Canvas Attributes. We're going to change this to inches. And then we've got 0.1 as our grid size. That's perfect. But we know we're going to need to offset by half a grid. So we'll do 0.05 as our snap size. Okay. So we said there were 0.6 is the distance vertically between the pads. So we'll come down 0.3, right? and we'll make our 3 pads for the bottom, and then we'll go up 0.3, 1, 2, 3, but these ones will be offset by this on the center axis. So now we've got our footprints. Now let's talk about pins. I didn't do them in the same order, so that's pin number 4. So I need to go back and look at my pins. This should be pin number 1 on the diode section, and then this is pin 2, and then this is pin 3. If you just throw your pins down and don't change look at your numbering, you could end up with big problems there when you go to route your actual traces. Let's just verify that. So the way he's got it goes into this end of the non-stripe side and the stripe side. So we're looking good. Alright, now we need to do the drawing part. We're going to switch to the silk screen layer right here, and we'll grab our, well actually we'll use the line, which you use the wire for lines. And we decide how big. Let's look at our footprint here. We know these are 0.1, 2, 3, and then 4. So we're 4 wide, and then we're basically 1, 2, 3, 4 tall. Right? So we want to center that. So we want to go out 2 here, come down 4, go across 4, and then he puts a little jog there, and there we go. Now we just need to draw the diode here and the resistors here. So to do that, we're going to change our snap size. Again, you right click. You can click here for snap size, but you're sometimes you get weird selections there. So you have to go to canvas attributes, and I'm going to change this to 0.01. There we go. You always get this little error. Just ignore. And same thing, we're on our silk screen layer. So I'm going to drag it this way to give me some more room here. And then I'm going to draw my diode like this. Again, this is what's going to show up on your printed circuit board. And I got a little, wonder if I can fix that. That's going to look a little funky, but that's alright. And then I'll do another line for the line on the diode. Then I'll grab the center here, come out to about here. Now wait, hang on. I'm just going to grab that there, drag it up here, come on in. Alright, that looks pretty good. Hit escape to get out of that, and then we got to do the resistor one. So we've got a line that goes straight up, photoresistors, and then another line, and then another line, and then I'll just do a little it's not perfect, but it doesn't have to be. Alright, so there's my symbol. Like I said, it's not perfect. Don't judge. Alright, we've got this done. This is the Vactrol. It's going to use the U prefix. We can leave that alone. We're going to save this. We'll call this 3-pole double throw. Oops. Vactrol footprint. When I go to my library, you'll see a few of these because I did a run through, of course, so I wouldn't be too messed up. Now what we need to do is we need to edit our main schematic symbol and add that footprint. So we go to our library and we find this one here, and we're going to right click on it and do edit. Now this has to have a footprint, so we're going to click over here in this section, and I'm going to look. Now one thing that kept kicking my butt was that I didn't have this tag. So let me go to my favorites real quick. What I need to do is refresh it. See there, that's an old one. And let me go to all libraries. Okay, there's the one that we just made. Notice it wasn't there because it doesn't refresh. This is that same refresh bug. So you always have to kind of go to something else and refresh. If we click on it, it looks good. If we look at my previous ones, oops, I see what I did. I got my footprint confused with the 3-pole double throw. So excuse me, let's edit that. Let's go to our footprint manager. Oh gosh. It's under Tools, Footprint Manager. As you were, let's go to Library, and we'll go to Footprints up here. And the one I just did, I'm going to edit that. I'm going to go File, Save As, and we'll change that. Remember, this is a VTL 53C/2 Vactrol footprint. Okay. Sorry about that. You get to see the mistakes along with everything else. Alright, so now let's associate that footprint with this schematic. Remember, I said you gotta go out something else and then go back. Now we should have, there it is, and it looks correct, and we'll update it. Then we close it. We look to make sure it's showing up here, and we'll go ahead and save this. Now let's see if it works. We have our guy here. Now let me delete these out because again I want to refresh. So I'm going to go to my library. I'm going to go back to symbols. I'm going to choose the first one, stick it in here. Choose the second one, stick it in there. And let's look at it and see. Now you'll see that the footprint is associated correctly. Let's go ahead and make a PCB. I'm not going to check the nets because this is just a test one. Oh, I have to save it first, sorry. Let's make a PCB. Let's check our footprints. Okay, 1, 2 is correct. So this one, 3, 4, 5. What's the problem? Okay, so the footprint I messed up. I left a pad 4 on there. So let's go ahead and fix that. And thank you for telling me. So to fix that, we're going to go to our library, and then we'll go to footprints. And I'm just making all kinds of mistakes, but that helps you guys see how to fix them. So we're going to go ahead and hit edit. Hit cancel there. Now if we look at this pin, this is pin 4. This is supposed to be pin 5, but it says 4. So I got to save that, fix that. Now it's showing 5, 4, 3, so it should work correctly. So let's go ahead and save it. Close that out. Now I don't know if this is going to refresh. Yep, okay, so this time it popped right up. It brought in our schematic, and it did that. What we could have done too on our footprint is we could have put the text on here, VTL, you know, the information on there. I skipped that step, but you can always label your footprint as necessary. So we'll go ahead and drag this guy and this guy to their rough locations. Alright, let's do that 3-pole double throw switch. This one has a little bit trickier dimensions. That's why I think it's a good candidate. Now I probably could find this one in the library. I did not find the Vactrol, but I probably could find that other one. Let's go to schematic. Dang it. That was a schematic. I need a symbol. So file, new, symbol. Alright, now we're going to do our symbol for our switch. This will be pretty quick. We just need some circles. Alright, and then we'll grab another circle here in the middle. And then we'll switch our snap size to 1. Grab a line, go to the center of this circle, make it like that. Okay, there we go, and now we need to add the pins. We can do this before or after copying. It's actually probably easier to do it after. So I'll do a Control C and Control V. I need 3 of these, and I'll just get them positioned like that. Alright, 3-pole double throw. Now we'll just start doing our pins. Now we want to number our pins 1, 2, 3. 1, 2, 3. This is the middle pin. So go ahead and set those on. Now remember, we want this to go on an intersection. So let me do that. I'm going to rotate this one. You could also do put these pins on first and then just relabel them all, but it's a little bit quicker to do it this way, I think. Alright, we got our 9 pins. Now, we just need to make these land on one of these intersections. So I'll grab the whole thing. Also kind of want to center it. It's not as important as this with the footprint, but that should work right there. And then I just need my box. And I want the box to go like this, I think. Let's see, right about here. And let me go down. No need to waste too much room. Alright, and then what we can do is we can add a text label. You just put it on first and then you double click it to change the text. 3 pull, double throw, toggle, switch. Now we want to change the prefix on this. So we're going to go over here to the U. We'll change that to SW. Right? For switch. And then finally I will grab that and center it and save. We'll call this 3 pull, double throw, toggle, switch. What are we at? We're 26 minutes, so if you're still with me, that's great. Thank you for watching. If you only bounce in and bounce out to get little parts, that's fine too. And let's create a footprint for this. This is the footprint that's a little more complicated. Go to File, New, Footprint. And let's change the background. Background is going to be a light gray. And click on OK. There we go. Let's look at our information. So if you look at this, the smallest interval between these pins is 0.7, which is 0.1 resolution, right? So we know we want our snap to be 0.1 millimeter, at least when we create these ones. So we've got 3 sets of pins. They're not circular pins. They're 1.2 wide in this direction, and they're 0.8 in this direction. So let's get started. We're going to start in the center. We'll put our first pad right there in the center. Now I remembered my snap. Let's change this. Let's see. No, it did not remember the snap. We'll make the grid size 1 millimeter, and the snap size is going to be 0.1 millimeter. Alright, that gets us in close. Now it was 4.7 across, but first what we want to do is make this pin, or this pad, the right size. So the pad is 1.2 vertically, this is the way I'm going to do it, and 0.8 horizontally. So we don't want to round. Well, we could use round. So what we could do is we could just say, let's make the width 2 millimeters, and then we can make the whole 1.3 diameter, and that gives us enough room to solder that guy in there. Let's go ahead and go with that. If you want to change it to an oval, you can change the whole shape as well as the shape of the pad to oval, which would give us more vertically, an oval shaped pad. But for this purpose, we're just going to stick with this. Now that I've edited that pad to make it the right size, I'm going to copy it and paste it. Now we know these are 1 millimeter snaps here. 1, 2, 3, 4, and then we want to go 0.7. So we don't really have to get it right on the first shot. We can click on it here, and if we look at the X, center X, it's minus 4.6. So we want minus 4.7. That gets us to the right spot. And I'll do another paste. This time I'm just going to roughly place it centered on the axis, and then I'll look at that. It's at 4.9. It should be 4.7. Alright, so now we have those correctly spaced. What we can do here is we can copy this. So we really don't have to change the snap to 0.1 because we're placing it more precisely by using coordinates. But that's just something I like to do. Now this one, center Y, is 4.1. If we go back to our diagram, it should be 4.8. Right? They do that so that you can't put it in the wrong way. If these were the same, you could just rotate it 90 degrees and it wouldn't fit. It would fit, I should say. This way they make it a little bit different so that you can tell that you're messing up and you're trying to place the component the wrong way. Alright, so what do we do now? Now what we do is we change this height to 4.8. That gets it there. And then we'll do another paste down here. Get it roughly centered. Okay, that's not centered, so let's fix that. The center, let's drag it. Let's get it centered that way. Alright. And then center Y is going to be minus 4.8. Alright, and then we can always check, click on one of these. Okay, the center X is 0, so that's perfect. So now we've got our basic pads. Now remember, we got to number these pads. 1 is going to be 2. It's going to be 3, 4, 5. Hopefully I don't miss one this time. 6. Of course I did that on purpose just to show you guys how to fix it. 7, 8, and 9. If you zoom out, you can't see the pad number, but you zoom in and you can see the pad number. Alright, now we just need to do the silk screen. So we're going to switch to that top silk screen layer, grab a square here, and we're just going to roughly draw it on because we're going to change the dimensions to match the actual item. This one is 18 tall by 13.2 wide. So we click on this guy, we say, so it's 18 tall by 13.2 wide. 13.2 wide, if you divide it by 2, you get 6.5, 6.6. So we're correct in the XY. We just need to change the width to 13.2 and check it out. Looks like it's centered properly. And then the height is 18, so let's change that to 18. And then it's going to start at minus 9, which is half of 18. I messed that up. What did I do wrong? Oh, I did the X instead of, that's supposed to be minus 6.6. And then the start Y is going to be 9. There we go. Now we're centered. If we want to, we can add a circle on there. Just draw a circle. In this case, it's 6 millimeters, so the radius would be 3 millimeters. And then I just want to center it at 0 and 0. That's the circle that corresponds to the hole cutout for the shaft of the switch. And then finally, we can add our text in our silk screen. Click on the T, click here, hit escape, double click. We'll call this 3-pole double throw switch. That fits in there nicely. If your text is too big, you can click on it, font family, change it to this demi light, and it gets smaller. So I tend to just stick with the fonts that are provided. I have not messed with using different fonts. Alright, so we have to save this footprint. We'll save it. We'll call this 3-pole double throw underscore toggle switch footprint. We'll save that. We'll close this guy out. Alright, now we need to associate it. I'm going to go ahead and delete. Well, that's okay. Let's go back to the library, and we're going to go back to symbols, and we will find our toggle switch. There it is. So we'll right click on it, edit, and then I'll click over here in the footprint, and then I will look for the one I just made. I don't see it, so I'm going to refresh it by going to a different library and then back to mine. And this is the one that I just created. It looks correct. And you'll see that all the pins, if I had looked at this last time, I would have noticed that the pin was messed up. I didn't do that. So just take a look and make sure your pins are mapping correctly. 1 goes to here, 2 goes to there. And then I'll update that, and I'll close it out. Now I can close this, save this schematic symbol, and close it. Now, if I put it in, you notice it does not have the footprint. That's because I still had it selected. You got to go back into your library. Again, switch to a different library, and then go back. And there is our item. Let's place it, close it out, and then let's just create the PCB to verify that it looks. You can see when you select on it, it has the 3-pole double throw, and you see that the text is a little messed up. I'll have to investigate that, see if I can figure out how to fix that. But anyways, let's create the printed circuit board. We're not going to check the nets. Oops, got to save it first. I always forget that step. Convert, don't check the nets. Cancel. Now we have our switch footprint. Looks good. Alright guys, so that's it for part one. Just kind of showing you how to create schematic symbols as well as the footprints that go along with them. I hope you enjoyed the video. If you have any questions, put them in the comments and I'll do my best to answer them. And look forward to part two. In part two, I'll have already created the schematic because I've already covered that, so I don't want to bore you with too much info, but I'll have this schematic completely put in, and then we'll talk about the process of creating how to organize it when you're doing a multi-stacking PCBs. And I have some opinions on that and ideas and a little bit of experience that I'll pass on to you in regards to that. So again, I hope you enjoy the class, a little tutorial, and we'll see you next time.